So myself Mahesh. So I'm going to teach a probability theory and random process subject. So the name of the subject is probability theory and random process. So before going to start the introduction to the this subject, so we have to know some basic definitions regarding this subject. So the first definition is we have to know here is sample space. Sample space. So the sample space is always indicated by a letter capital S. So the definition of this sample space is the number of. So it is the number of outcomes outcomes of an experiment of an experiment. So the experiment here is we can call that experiment name is throwing a coin. The experiment name is example of that experiment here is throwing a coin or a die, etc., etc., whatever it may be. So so here the example, suppose the if you consider the first example, so throwing a coin. So coin has two faces, no? So that's why it has it has either tail or head in that experiment. So totally you are having two number of outcomes in your throwing a coin experiment. Whereas in case of second experiment, it is throwing a die. So die has totally 1 2 3 4 5 6, totally six faces. So the total number of outcomes here is 6. So this is the brief introduction to the sample space. Okay, so this is what about the sample space. So moving on to the next example, a next concept. So the sample space. So types of sample space here. The next concept is types of types of sample space. So types of sample space. So here basically in the signals we are having continuous signal and discrete signal. Here also we are having two types. One is discrete sample space, discrete sample space, and the second one is continuous sample space, discrete sample space and continuous sample space. So coming to the first example, the first type of the sample space, discrete sample space. So as the name indicates discrete, here the value should be discrete. That means here the example is previous example itself, it is throwing a die or a coin. So this is the first example of discrete sample space. Not first example. Here two examples we are having, throwing a die or a coin. So similarly, the second experiment is, so continuous means there should be no discrete values. Like in the previous example, continuous means suppose you are having a circle. So circle you are having the values from 1, 2, 3, and it is 4. That is 4. And here you are having a needle, indicating uh, the outwards of the your circle. Like you can assume here it is a analog clock. So suppose if this needle is not always constant, it is moving continuously. That means it can stop between either or two, between between one or two, it can stop anywhere. It can stop. You cannot tell that needle stops at either 1 2 3 4, not like that. You can tell that it can start at 1, it can start at 1.01. I mean it can stop at 1.02, 1.05, whatever it may be, different values. That means the sample space of that here, if you see this one, between 1 and 2, you are having infinity number of possibilities to stop that needle. Infinity number of possibilities. Number of possibilities. So in this case of example, here you are having totally how many number of sample space? Totally the number of sample space in this case of continuous sample space is infinity. Infinity sample space. Whereas in case of your discrete sample space, the number of outcomes is the limited one. So this is what briefly about the sample space. Now moving on to the next one. Next one is event. Next one is event. So next example is the event. So these are the two definitions we should know before moving on to the probability concept. So what is meant by event? So the event is nothing but the subset of the sample space. Subset of the sample space. So the event is nothing but the subset of sample space. So example, how it is represented. Suppose you are having throwing a coin. So here you will get either tail or head. So what is the event? How event is represented here is, so the event might be, I am here, I am defining my event is, what is the probability of getting getting a tail when coin is tossed. Coin is tossed. So here the getting tail is my event. Getting tail is my event. So another event, getting a head. Another event, you can define number of events here. Okay, so the example of event here is getting a tail or getting a head. Okay, so you can call this one as subset of, the event might be called as subset of sample space. Why it is called subset? Because tail is a part of your sample space. Getting a tail is part of your sample space. Getting a head is also part of your sample space. That's why the event is always called the subset of sample space. So that is what about the event. Now moving on to the main definition. That is our main this one discussion is probability. Probability. The main thing is probability. So how it is represented? So usually the definition of probability is somewhat complex. So I am giving the simplest definition here. So you can call a probability is a ratio of two numbers, that is a by b, Okay, two numbers, or else I will take like this. So small letters I will take a by b. So here these are two numbers, and the probability I can represent here is p. Here is p. So I am assuming here my probability is ratio of two numbers. So ratio means we should know here what is a, we should know here what is b. You should know what is a and you should know what is b. Okay, so a equal to a equal to here number of outcomes, number of not outcomes, favorable outcomes, number of favorable, let me, number of number of favorable outcomes. I will explain later the definition. It is the definition, that's why it should be like that only. And here the b means, so here b is there, no? So b means b equal to number of outcomes, number of outcomes of sample space. So that means a by b, you are here, I told you that it is the ratio of two events a by b. but I am telling denominator is sample space. So that means denominator is always greater than or equal to numerator. That means here suppose it is A, it is B. Here the denominator is always here that the condition is A must be less than or equal to B. Must be less than or equal to B. That is the meaning. So next one, I am telling you next one. So the definition of probability like this, that the probability I am writing again. The probability is defined as the ratio of it is the ratio of number of favorable outcomes to the total number of outcomes. Here here I may again telling you, total number of outcomes means it is nothing but sample space sample space sample space. Suppose I am giving a one example here, see this. So suppose again take throwing a coin. Here how many you are having? In coin example you are having two sample spaces. So I want the probability of getting tail. So probability of getting tail means I'm just now I told you it is the ratio. That means that is number of favorable outcomes of tail 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 to the total. That means see here favorable means here, see here, in the total number of outcomes in the sample space, the favorable outcomes to the tail is the favorable outcomes to get the tail is, see here. So tail is only out of two. So that means in the numerator you are having 1 divided by, so in the denominator total number of outcomes is what? T and H, that means 2. So 1 by 2 is my probability of getting tail. Similarly, so suppose you take probability of getting head. Here also number of favorable outcomes of head is 1 divided by total number of outcomes is the 2. 2. So and I am giving one deduction here. See here. So what is 1 by 2 plus 1 by 2? 1 by 2 plus 1 by 2 is equal to 1. That means here the probability of getting tail plus the probability of getting head is always is equal to what? 1. That means the probability of the probability of sample space is always equal to 1. It is a main example, or not example, main theorem or main deduction you should remember. So the probability of sample space is always equal to 1. Okay, now moving on to the next one, axioms of the probability. So there are axioms of the of the of the probability. So axioms of the probability, see here. So just now I told you probability of an event, suppose assume an event is A, is always must be greater than or equal to 0. That means it is a non-negative number. It is a non-negative number. Why it is a non-negative number? Just assume you are playing a game. Playing a game means tossing a coin, tail or head. So here suppose if you want tail tail So what is your probability of winning? Probability of winning is always equal to 1 out of 2 chances. 1 out of 2 chances, that means you can get tail, you can get head, you can get head. So 1 by 2 is your chance of winning your game. So here there is no question of getting -1 or minus 0.5 like that. So that means your probability is always a non-negative number. That is the first axiom you should remember. And the second one, just now we told you, no? So the second one is the probability of sample space P of S is always equal to 1. The probability of sample space is always equal to 1. And third one you should remember. And I told you what is the maximum limit of probability. What is the maximum limit of probability? I told you it is not a non-negative number. Okay, that means it starts compulsorily at 0. And where it ends? So see here, the ending point is always, it should be less than P of A less than or equal to 1. So the probability might be minimum 0. That means you lost the game, and the probability is maximum value is 1. Maximum value is 1. That means here you compulsorily win that game. So these are the three axioms of probability. So now we'll do one problem on this probability. See here. So the problem is like this. So the problem is, one experiment is there. They told you like this. One experiment. That experiment is consisting of rolling, rolling two dice. Rolling at a time two dice. So they ask you first one a equal to sum equal to 7. So b equal to 8 less than sum less than or equal to 11. So suppose you are taking, I am defining two events, sum equal to 7, and sum less than or equal to 8 less than sum less than. So what is meant by sum here? Sum is equal to, here we are rolling two dice. So two dice means two dice shows two faces. So the sum of two faces showing, so, and here what they ask you is P of A and P of B. That is the probability they are asking you. So see this problem. One of the experiment is there. Here they are rolling two dice. Okay, and they have defined two events. What are that events? That events are a sum equals 7 and b sum must be always less than 8 less than sum less than or equal to 11. And what is meant by sum here? They told you the sum is nothing but addition of two values, that two dice is showing one values, no? So suppose you are getting a one die as a value of 1, I mean showing value of 1, another die showing a value of 5. So the sum is 1 plus 5, that means sum is 6. So like that, there is a chance of anything, that means 1 plus, there is a chance 2 to 12, that the sum might be minimum value is 2 and maximum value is 12, anything you can get. So that, and what they ask you is finally P of A and P of B. So this is the probability, simple problem. So before doing anything, first thing we have to do is you should define the sample space. What are the chances of getting sample space? So the sample space here is I am defining. So how many I mean dice are rolling? Two dice are rolling. That means the number of outcomes is, each one gives you 6. So 6 into 6, that means 6 square. That means total number of outcomes of your experiment is 36. 36 number of chances are there when two dice are rolling. So now I am going to tell you that sample space how it is look like. So the sample space is like this. It is suppose the dice are showing 1 comma 1 and 1 on the first die and another one is 1 on the second die and 1 3 1 4 1 5 1 comma 6. So here first one is indicates the first die, second one indicates the second die. So there is a chance. Next one is 2 comma 1, 2 comma 2, 2 comma 3, 2 4, 2 5 and 2 6. Okay, like that and so on and so on. And the last one is 6 comma 1, 6 comma 2, 6 comma 3, 6 comma 4, comma 5 and 6 comma 6, 6 and 6. So this is the sample space. So this is the sample space I am getting when two dice are rolling. Okay, now what they ask you is so see here. So the number of outcomes means nothing but you can have two dice. So one on the first die, another one on the second die. One or two, 1 3, 1 4, 1 5, 1 5, 1 6. Like this, you are having totally 6 combinations. So first one is fixed 1 2 3 4 5 6, and second one is changing. So these are the number of chances, and the final one is here. If you add all this one, totally 36 chances are there. So that means my sample space S is equal to 36. 36 is my probability of, so not probability, total number of outcomes of your sample space. So first you should define the sample space. Okay, now moving on to the first one. So what they show here, sum is equal to 7. Sum is equal to 7. So sum 7 means you can have 1 on first day, 6 on second day. You can have 2 on first day, 5 on second day, 3 4 4 3 5 2 and 6 1. So these are the chances, and these are the different favorable outcomes to say that it is belong to an event A. That is a event entity. What they told you here, that event is sum is equal to 7. Sum is equal to 7. Sorry, sum is equal to 7. Okay. So I want to find out the probability. I want to find out the probability. So how probability is represented? Probability is represented P of that event, P of A, which is equal to how many number of events are there? Here favorable events means 1, 2, 3, 4, 5, 6. Totally 6 events, no? So that's why 6 favorable events divided by total number of events. How many events are here? The events are 36. So 6 by 36. That means so the probability is 1 by 6. This is how we have to calculate probability of the event A. The event A here is what they show you is sum is equal to 7. Sum is equal to 7. Okay, what is the next event? Next event is B 8 less than sum less than or equal to. Just say, remember here equal to 8 less than means sum must be less than 8. So sum must be less than 8 means you should not consider 8. Greater than 8 means until 9, that means 9, 10, 11. What that is the, those are the chances. So now see here. So for the event B, so again I have to find out the probability of, I mean, not my favorable chance. So what they told you, B means B means 8 less than sum less than or equal to 11. So that means you should exclude 8 here, and you can write like this. I mean, I can change this event into I want to get 9, 10 and 11 when my dice is rolling. Two dice are rolling. So 9 means you can get 3 comma 6. You can get 4 comma 5. You can get 5 comma 4. You can get 6 comma 3. 6 comma 3. Okay, that is in case of 9. Any other chances? So these are the chances only. Now this is 9. Next 10. 10 means you should get what? Suppose I will fix it as 4, 4 comma 6. That next one is 5 comma 5. Next one is 6 comma 4. These are the three chances for the 9. Then what is the 11? 11 chance means suppose there is 5, this one is 6, next this one is 6, and this one is 5. So here this one is 4, this one is 3, this one is 2. Is there any other chances? So just remember, check here, 3 comma 6. Suppose I'm taking first one is 2, then in the next should be 7, but because in the die there is only maximum limit is C 6, no, that's why two chance, I mean first die two chance is not valid here, so that's why. So it starts at 3, 3 comma 6, so 3 comma 6, and I'm changing, increasing this one is to 4, 4, and in that case it is 5, and it is from 5, 5 is 4, so 6 comma 3, and that totally 4 plus 3 plus 7, so totally I am having how many chances here? So my chances are totally 9 chances to get sum is might be say 9 or 10 or 11. So I want to find out the probability. So my probability is P of B. So by P of B is equal to number of favorable events here is how many? 9. 9 divided by total how many? 36. So that's why my probability is 1 by, my probability is 1 by 4. This is how you have to calculate the probability. Suppose, and the last one is, I will see here. Suppose they ask you, they ask you what is the, suppose another event. So they ask you what is the probability that I am getting exactly sum equal to 12. Suppose they gave you sum equal to 12. So sum equal to 12 means you are having only one chance. That one chance is like this. That one chance is nothing but 6 comma 6. So both die should be 6 and 6. So that's why here having only one chance, and my final chance, and my final probability is equal to, favorable event is only one, but the total number of event is 36. So my probability is 1 by 36. 1 by 36. So this is how we have to find out the probability of any event. Any event. Okay. So these are the different types of problems. And if you see another problem, suppose, see here, see here, another event, that event defined like this. Another event is, another event is d. D means some they gave you some greater than 10, some greater than 10. Suppose they gave you like some greater than 10 means there are two chances. Greater than 10 means 10 is not included here. That means we should have either 11 or 12. So some 11 might be chances. What are the chances of getting 11? 11 means how many? 5 comma 6 and 6 comma 5. These are the two chances only to get the sums 7. I mean 11. And the next one is 12. 12 means here also 6 comma 6. So totally how many chances? 2 plus 1, totally 3. So your probability of getting D is equal to 3 by 36. That means 1 by 12 is my probability of getting the sum greater than 10. Sum greater than 10. So we can define any events here, any number of events here of your own choice. But for every event you should get that probability. So some cases they gave you, some cases they gave you intersection also. That means what is the probability of getting a here? Suppose C intersection D, C intersection D. So here they told you we have defined two events, no, C and D. So I am going back to C. C means sum equal to 12. D means sum greater than 10. So intersection means, see here. So C means sum equal to 10. Sum equal to 10. Intersection, sorry. C means sum equal to 12. 12. D means intersection sum greater than 10. Sum greater than 10. They should both satisfy. They should both satisfy where sum equal to 12 and sum greater than 10. If you consider 5 comma 6, sum is 11, but the intersection means sum here both should satisfy. Sum 12 is not satisfied, so this one is not valid for me. So if you consider this one 6 comma 5, here also sum 11, but if you consider this one 6 comma 6, so that means sum 12 it is satisfied, and you should consider here sum greater than 10. So 12 means sum greater than 10, so finally it should satisfy. So the intersection point is like this. Intersection point is out of 3, how many you are having? Only one, so that's probability is 1 by 3. 1 by 3. Sir, you can ask me, sir, why you have not taken 36 here? Because I am taking the events individually. C event, D event, and the addition of two events is nothing but my total number of events. That's why I am taking 1 by 3 here. Okay, so this is how you have to find out the intersection of all the events. Intersection of all the events. So with this, sorry, actually it is 1 by 36, not 3. So total number, you should consider total number in your sample space. So 1 by 36. Okay, so this is how we have to do. We have to calculate probability of any event, whatever it may be, given choice. So with this, I conclude the today's introduction topics, probability and sample space, event, and one example on probability. So in the next class, we'll see some theorems on probability and addition theorem of probability, total probability, joint probability, like that. So thank you.